this is an empanada box right here.
Okay.
I don't recall what empanada stands for or if it was just a funny name. We have a lot of acronyms around here, but some of them are not acronyms.
Like the other later, what's that?
This one is Strata.
The evapolator, something like that. What is it? I forget. It'll come back then.
So this goes into vacuum, under vacuum. These two grooves hold O-rings here, and this polycarbonate box seals over the top of the O-rings here.
So it's totally like airtight?
Yeah, completely airtight. We're pumping down to about 1,000th of an atmosphere. And this is going to be positioned upright in a frame where it has about 4 of these boxes.
Okay.
And this
Four
is
of these?
No, 4 of these
the
entire
whole
units
thing.
in like
Okay.
a big frame. I mean, it's about 4 feet wide, or 3 feet wide, I should say.
Yeah. Okay.
So this is going to be filled with our regolith simulant, this dish right here, simulated asteroid material. And this stepper motor is going to actuate this little ruler back and forth as a probe into it under the microgravity conditions during the flight.
Okay.
We have a camera here looking to see what's going on, and there's a load cell here that's like in like a normal bathroom scale that measures the amount of force that's pushing back on this ruler as we're sliding it down into the material.
Okay.
And this is giving us information about how the material properties change under different gravitational loads. Because, stepping in dirt on Earth is very different than stepping into, say, lunar soil, or stepping into the loosely packed material on an asteroid. We need to know how that material behaves if we ever want to go build.
So you're saying like on Earth, instead of making like a footprint, it might be like a lighter footprint or something?
It might, yeah. The material is just going to behave in an entirely different way. So if there's less gravity, you can think that things are going to be way less packed. So you might actually sink, like something might sink a lot deeper from an impact. But you would, of course, also weigh less. So maybe that the footprints will be about the same. It's really interesting stuff.
Yeah.
I'm not really the guy to ask about the science and the application of the data.
Did you build it?
I did not. This was before my time.
Okay.
But this is what we're basing the new experiment on. So we're still going with
that kind of thing.
Yeah, so we're going to try to make things a lot more compact this time, not do it under vacuum, because the results of this experiment from last time determined that doing things at atmospheric pressure versus in vacuum, they weren't all that different. So there wasn't a whole lot of gas interaction as far as the force results from this load cell. So what we're doing is we're going to try to put 8 of these inside of a Blue Origin locker that goes up on a suborbital flight. So there would be, say, so we're actually modifying these. So we're it's going to be oriented sideways like this, and there's going to be some G's coming like that. And this is going to be a taller box. So instead of having 1 right here in the center, imagine that we have this as a double high, and we go and have 2 of these probes going in, and then multiply that by 4. So 1, 2, 3, and 4 here. Hi, Sarah.
Hi.
So right now I'm drawing up a proposal for that experiment on SolidWorks and getting a good model to see if NASA will give us some money to make it.
So what's the mechanical engineering part? Are you just like doing the same as anyone else, or is it kind of like you do a different part?
So as the mechanical engineer around here, I generally design parts. So all of this is assembled of multiple parts, and these aren't things that you can just go to the store and buy. So you need to model out how all these things will fit together and construct them in the software. And then eventually you're going to order the material, you're going to send it off to the machine shop, or in some cases 3D print it like you saw it running over there. Also, those are your pieces, yeah, you found them. And then go ahead and assemble them.
So you design it using a software, and then does that software go to the machine shop?
So the software, I design individual parts. So let's say this little dish might be a single part, right? And then this metal plate that screws on here might be another part, and this bracket's another part. And then in the software, I'm able to assemble them all and add screws. And then I break it down part by part. I make those parts into drawings which have a standardized. There's a certain standards called GD&T, Geometric Dimensioning and Tolerancing. It's a standard set by ASME, the American Society of Mechanical Engineers, and using those standards, I'm able to come up with these drawings that I can send to the machine shop. which will allow them to know exactly what I want to build. Because if you're not entirely specific about, okay, what's this dimension from here to here, they might, this little outcropping might be here instead of up top.
Okay.
They need to, we just need to be very specific with that.
Oh, okay. Yeah, I guess if you have a part, it has to be exactly
Very exactly
the way you
defined,
want.
yeah.
And we never think of this because you just buy parts and you don't
Yeah, so something like this. I'm actually
That's
not familiar with what this goes to, but no, we would have modeled all of this out, modeled out the holes, and specify which kinds of threads there are, because there's a million different kinds of screws. And you need bigger, you need a wider screw or a thinner screw depending on what kind of load it needs to handle. There's several different thread types that are appropriate for different vibrational scenarios, things like that. And so we'd send, like, you can picture, like a drawing. I can show you some drawings on my computer. We'd send a drawing specifying the distance from here to here, of the hole from here to here, from there to this hole, from there to the center. And we'd specify, in this case, what kind of drill bit it is, because, normally I have my drill with me just for helping out. So normally, whenever you go to the hardware store, you get drill bits like these.
Yeah.
Well, if you go to a machine shop, they're going to have like 200 different drill bits. It's crazy. Yeah.
So you really have to know,
Right. And like this is a drill bit size chart right here. So I mean, there's a million different sizes that we can specify here. It can be 1/64th. It can be a number 16. It can be the letter I. I mean, anything that you want, really.
That's kind of crazy. That's interesting. All right. So,
Do you want to see some of those drawings?
sure.
Just to see